Okay, hi everybody. So this is just a quick video going over section 7.7. Make sure you put all work on the guided notes and make sure everything is clearly written out. Every example that I do, you do as well. Okay, so sorry about that. In section 7.6, we talked about how do we add and subtract polynomials. Section 7.5, jumping back, was just basics on how we identify them and talk about them and what's their degree and whatnot. And section 7.6 was how do we add and subtract. So now what we're doing in section 7.7 is we're going to multiply polynomials. Now multiplying polynomials is one of the really big topics of Algebra 1. So this is extremely important. Okay, now remember we learned this way back at the beginning of chapter 7. When multiplying powers the same base, we keep the base and add the exponents. Like if I've got an x squared times an x squared, it's an x to the 5th in the end, right? You add the two exponents together, okay? So let's take a look at what we have. Now, remember, we can talk about this in a new way since we've done section 7.1 now. This is a monomial times a monomial, right? A monomial times a monomial. So what I can do here, when it's a monomial times a monomial, is multiply all common parts together. I don't need to do any sort of distributive property because there are no plus or minus signs. So what I can do is I can just simply multiply the numbers together. So I've got 6 times 3 to get 18, and then I can multiply the variables together. So y to the 3rd times y to the 5th. Now remember, y to the 3rd times y to the 5th is going to be what? Well, 3 plus 5 is y to the 8th, right? Okay, and that's my answer. Okay, so now what we're going to do is we're just going to progressively keep amping it up. We're just going to keep pushing and pushing and pushing and see how hard we can make this. Okay, so what if we put a couple variables in there? Same process still applies. All I'm going to do, because there's no addition and subtraction going on in either one of these, this is all just monomials, right? What I can do is I could just multiply common parts together. 9 times 3 is 27. M times m squared, remember that's an m to the 1st. M to the 1st times m squared is m to the 3rd. And then we've got n squared times n, which is n to the 3rd. And that's my answer. Okay. Let's keep it going. Okay. So now here we have 2 times 5, which gets me my 10. R squared times, well, there's no more r's to combine it with, so we just leave it right here. And then we've got t times t to the 3rd. Remember, that's t to the 1st times t to the 3rd, t to the 4th power. Okay, so that is when you take a monomial times a monomial, okay? Monomial, single term times a single term, no addition, subtraction signs going on. Now, when you have a monomial times a polynomial, something more than one term, you have to use the distributive property. Now, we've used the distributive property since middle school, so we're pretty good at that now. Now, do we understand that, even though it's just a 4 on the outside, it's still just the distributive property. That's still a monomial. So all I'm going to do is a distributive property. Distribute, distribute, distribute. Now all I'm going to do is just do it 3 times. 4 times 3 is 12 x squared. 4 times 4x is 16x. 4 times negative 8 is 32. Okay? That, we could have done before this lesson, right? That's not too bad. But what if it's a monomial with variables in there as well? Now, this is when it starts to get a little tricky. Remember, if it's a monomial times now this is a binomial, right? I distribute it in, right? Okay, so this is like taking 6pq times 2p, right? So this is like jumping back to the first slide with all those monomial times a monomial, right? This monomial times this monomial. 6 times 2 is 12. P times p is p squared. Q times, well, there's no more q's there. And so that was this. Now let's do this, right? 6 times negative 1 is a negative 6. P times, well, there's no more p's there, so just p to the first. Q times q is q squared. And that's my answer. Now, I just have to make sure, are these like terms? No, they're not like terms, so I don't combine them together. And that's my answer. Okay. Now we've got another monomial times a monomial, but in this, monomial times a binomial. But in this one, I've got a fraction. Still the same rule applies. I'm going to distribute this monomial, this whole monomial on the outside, and into those two parts. So let's do this part first, right? 1/2 times 6, 3. X times x, and all I'm doing is just multiplying common pieces together. Y times y is y squared. Now let's do this. 1/2 times 8, x squared times x squared, y times y squared. Okay, and now are these common terms? Nope. Okay. All right, so what we did in the last two slides was a monomial times a monomial, and then a monomial times a polynomial. Okay, so what if we've got a binomial times a binomial? Binomial times a binomial. Well, we basically do the distributive property more than once. Okay, so here's what we've got. I'm going to take x times x. Like I'm going to treat this binomial as two separate pieces. Binomial, two pieces, right? So I'm going to distribute into the second one with here, and then I'm going to go here. So x times x would give me my x squared, and then x times 2 would be 2x. And then I'm going to do the same thing. Now watch, I'm going to put this in different red, and I'm just going to make my little arrows underneath it. 3 times x would be 3x. 3 times 2 would be 6. Okay? And now I just combine any like terms that I had. So take a look, and I've got these middle two terms being like terms, right? So my final answer would be x squared plus 5x plus 6. Make sure all answers are in standard form. Okay, so what did we do there? Again, we did the distributive property, but we did it twice, right? Once for my first term of the leading binomial, once for the second term for the binomial in the front. Okay, now there's a way to remember how to do this, right? You can remember doing the distributive property, but there's a way to remember how to do this. It's called the FOIL method. Now, the FOIL method. All the FOIL method really is saying is that I multiply. Now, FOIL is just an acronym. You know, we know what acronyms are. Acronyms are like, ways to remember how to do things by giving it giving it a word. There's an acronym for all of the Great Lakes. I don't know if you guys have seen this before. The word homes helps you remember all the Great Lakes. Like this is Huron, Ontario, Michigan, Erie, and Superior, right? Those are all the Great Lakes. It's a word that helps you remember other things. This is just a word that helps you remember other things. So F stands for first. First terms. Multiply the first terms together. And now when I say first terms, I mean first terms out of the two binomials. O stands for outer. So you're going to multiply the outer terms out of each of the binomial. So like this is the outer two terms, the one on either side. I stands for inner. Multiply the two inner two terms. And then L stands for last. Multiply the two last terms in either binomial. And then all you do is just add them together. Now look. Firsts, x times x is x squared. Outer, x times 2 is 2x. Inner, 3 and x make 3x. And last, 3 times 2 makes 6. X squared, and then you combine like terms. X squared plus 5x plus 6. That's what's called the FOIL method. Now, guys, guess what? I'm not trying to pull the wool over anybody's eyes. This is still just the distributive property, right? we still got the exact same answer as we did before. So I'm going to talk about the FOIL method, but please remember that it's just the distributive property as well. Okay. All right. Let's take a look and try an example. We've got s to the s plus 4 times s plus 2. Okay, s plus 4 times s plus 2. All right, so here we go. First, s times s squared. Outer, s times 2, 2s. Inner, 4 times s. Last, I'm going to make that last one. 4 times 2 is 8. S squared plus 6s plus 8. And there's my answer. Okay, just combine that like terms to get my 6s in there. You know what some people say? That you got to make a FOIL man. Look, you see, here's his eyes, his nose, and his mouth. FOIL man. Okay, sorry, enough of that. All right, let's try another one. Okay. So we've got x minus 6 and x plus 3. Two binomials, right? X times x. There's my firsts. X times 3. There's my outers. Negative 6 times x. There's my answer. There's my inners. Now remember, we're treating that as a negative 6. And last, negative 6 times 3. Combine like terms in the middle. 3x minus 6x is a negative 3x. And there's my answer. Okay. I'd like you guys to pause and try this one. Now it's a little bit more difficult because we've got squareds and stuff, but you can do it. Okay, we got 8m squared times m squared. 8m to the 4th. And m squared times m squared is m to the 4th. We've got 8m squared times 3n. So that's a minus. Now look, minus, negative. Minus 24m squared n. Inners. Okay, and it's a minus, negative n times m squared. Negative m squared n. Negative n times negative 3n, positive 3n squared. Ooh, this is a tricky one. It was a tricky for a couple of reasons. They're both minus signs, so watch here at the end. That's got to turn into a plus sign. Negative times a negative is a positive. Also, when you do your inners right here, we already lined up m and n as m squared n. So when you do your inners, and now it looks like you maybe should do like n m squared, but we've already done m squared n, and order doesn't matter in these terms because they're just monomials. We can switch them around and it's no big deal. So combine these two terms in the middle, 8m to the 4th, and now this is a negative 24 and a negative 1 m squared n, negative 25 m squared n plus 3n squared. That one was tricky. Ooh. All right, last two slides. Now, in the expression x plus 5 squared, the base x plus 5, the base is x plus 5. So if I've got x plus 5 squared, you have to multiply the two binomials together. Just like if we had like 3 squared, you know, that really essentially means 3 times 3. If we've got a 4a squared, that would be a 4a times 4a, right? If you've got an x plus 5 squared, you have x plus 5 times x plus 5. So if you've got an x plus 3 squared, you have to do an x plus 3 times an x plus 3. Okay, guys, I'm going to caution you against something. This is not true. You cannot just distribute the exponent. You cannot distribute the exponent. Everybody listen to me. Everybody write this down. You cannot distribute exponent. Okay, why can't you? Well, because that's a plus sign. You know, if this were to have been like an x times 3, that's a times symbol, squared, yes, then you can do x squared times 3 squared, right? You can do that. That's okay. But what you cannot do is do it when it's a plus sign. Plus signs are very different than multiplication signs. So back to the problem at hand. We have to do what with this? We have to FOIL this. X times x is x squared. X times 3x is 3x. 3 times x is 3x. 3 times 3 is 9. And I just combine like terms in the middle. X squared plus 6x plus 9. And that's my answer. Okay? Notice that it's very different from saying x squared plus 9. There's that 6x that we didn't even see if we would have tried to just go straight to this. So we cannot distribute the exponent. X minus 5 squared. So again, write it out. This is x minus 5 times x minus 5. First, x times x is x squared. Outer, x times negative 5 is a negative 5x. Inner, negative 5x. Last. Now watch out. Negative 5 times negative 5 is a positive 25. Combine like terms in the middle. A negative 5 plus negative 5 is a negative 10. That does not cancel out, folks. A lot of people might try to tell me negative 5 plus negative 5 is 0. No, no. Negative 5 plus negative 5 is negative 10. Okay, now here's where it starts to get real funky. Okay. So, you know, foiling was for a binomial times a binomial. What if you've got a binomial times a trinomial? Well, remember, essentially foiling was just using the distributive property. So all I'm going to do here is just use the distributive property. That's really it, folks. I know this looks like some big, bad, hard problem, but if you pare it down to what it essentially is, it's just two things that you're going to distribute in. Okay, what are we going to distribute in? We're going to distribute an x and then a negative 5. So let's do that. Let's distribute in the x. X times x is x squared. X times 4x is 4. I'm sorry. X squared times x. I got that wrong. X squared times x is x to the third. Because here's the power 1. Here's the power 2. Add them together. X to the third. I'm sorry. X times 4x would be a 4x squared. And then x times negative 6 is a negative 6x. Okay, now that's one distribution. Now I've got to do the 5. Negative 5 times x squared is a negative 5x squared. Negative 5 times 4x is a negative 20x. Negative 5 times negative 6 is a positive 30. See, all I'm doing is multiplying, guys. I'm not doing anything fancy. I'm just doing the distributive property. And now I just combine like terms. Start again with your highest power. Got to put it in standard form, x to the third. And then I've got a 4x squared and a negative 5x squared. So minus 1x squared, or just minus x squared. I've got a negative 6x and a negative 20x to make negative 26x. And then I've got that plus 30 sitting out on the end. Whoa. Guys, that's about as difficult as we can get there. Okay. A binomial times a trinomial. Let's try another one of those. Okay, let's try that again. Okay. 2x. Again, distribute this in here, here, and here. 2x times negative 4x squared is a negative 8x to the third. 2x times negative 10x is a negative 20x squared. 2x. Hold on. Pause for a moment. You don't need to pause. I need to pause. Hold on. We got a text from my wife. forgot to turn my little girl's alarm on. Okay, there we go. All right, where was I? And then 2x times 3 is 6x. Negative 5 times negative 4x is a positive 20x squared. Negative 5 times negative 10x is a positive 50x. And negative 5 times 3 is a negative 15. Okay? So again, just two different distributive properties going on. Negative 8x to the third. That cancels. $6x and 50 make 56x. And then minus 15 sitting out there on the end. Okay, last problem here. X plus 3 to the third. Okay. Just like x plus 3 squared was x plus 3 times x plus 3, x plus 3 to the third is just 3 times over. Okay, now here's what we're going to do. Here's the method for this one. Whenever you have a binomial to the third power like that, multiply those two together. So we got first, outer, inner, last, right? We got x plus 3, x squared plus 6x plus 9, x times x. And now what we're going to do, we combine like terms in the middle here. And now I've got to do another problem. I've got to distribute this in. X times x squared is x to the third. X times 6x is 6x squared. X times 9 is 9x. And now I do it with a 3. 3 times x squared is 3x squared. 3 times 6x is 18x. 3 times 9 is 27. And then I combine like terms. And then I've got 9x and 18x to make 27x. And then plus my 27 constant out there on the end. Okay. All right, I'll go over another one of these when we get to class tomorrow. All right, I'll see everybody later.